Okay, so today's lesson is going to be on monitoring air quality. So in other words, we're going to be looking at what kind of chemicals compose the air, as well as what kind of pollutants can go in the air and what the effects of those pollutants would be. So again, we're going to look at what chemicals compose the air we breathe. We'll particularly focus on harmful pollutants that exist in the air. It's going to be a pretty quick lesson today. By the end of it, you'll just be working on that monitoring booklet that you have already been provided. Anyway, let's get going. So air composition, the air we breathe is made up of mostly about four main things. The main thing, number one main thing here is nitrogen gas. That's about 78% of the air we breathe. Oxygen gas, the thing that we actually use in the air, is only 21% of the air we breathe, which to some people comes as a bit of a surprise because you might think most of the air we breathe is oxygen. But it's not, and believe me, that is a good thing. Too much oxygen can actually be toxic to people. Too much oxygen breathed in at one time is not a good thing. But I think the biggest issue with having a lot of oxygen in the air is if we had like a 100% oxygen environment, fires would be a lot harder to control, right? Because fires, of course, use oxygen to produce. If you have a high oxygen environment, you're going to see pretty big explosions from what otherwise would have been small fires. Anyway, argon is another thing that is in the air we breathe. It's less than 1% of the air we breathe. Carbon dioxide, of course, which we all know as being the gas that we breathe out. It's actually only 0.03% of the air we breathe, but that is still, of course, a significant portion of the air in the whole grand scheme of things, so it is important to note. And then there's other trace gases like H2, that's hydrogen gas, as well as neon gas. Water vapor, of course, forms a little bit of that as well. That, of course, varies depending on what the humidity is in a given area. But yeah, anyway, moving on. So the main focus for today is actually air quality. So yes, we talked about what actually air is made up of, but we need to talk about air quality, especially when it comes to, or comes from a perspective of air pollution. So air quality can be determined in generally one of two ways. You can either measure levels of pollutants directly. So that would be using a meter like this one. When I was in university, I actually had a summer job once. It was called a confined space gas analyst, and we used like this this machine kind of like this, and there was like a hose that this attached to, and you would stick it into like confined space areas. Anyway, long story short, what it does is it measures the concentration in parts per million of different harmful gases for whatever your meter is calibrated to, just to tell you what, of course, is in that air. And ideally, you wouldn't have much of anything in here, but still. One thing I noticed right on this is, I don't know how easy it is to see from a distance if you're watching this in class right now, but oxygen is on this meter, and it says it's 21% roughly of the percentage volume of whatever sample it just received. And look at that, it pretty much more or less matches up, which was, or what was on this, this pie chart here. So kind of cool. Anyway, I'm getting sidetracked. The other way of measuring air quality is by estimating emissions from pollution sources. Of course, when we talk about those gases on the last page, this is assuming just normal natural air. If we have pollution from certain factories or even natural causes like forest fires or volcanoes, that of course is going to change the quantity of different chemicals in the air. So yeah, anyway, moving on. So one of the chemicals that can be used as a pollutant is sulfur dioxide, SO2. Now, SO2 pollution comes from industrial processes. So in other words, from certain factories, sulfur dioxide can be released from that. But it also can come from burning fossil fuels. So in other words, even just operating your vehicle can produce sulfur dioxide. Now, the whole issue with sulfur dioxide is it produces acid rain when it's mixed with water in the atmosphere. So when it makes its way all the way up to the clouds and it mixes with the water up there, that actually can start like a little mini chemical reaction and form a type of acid rain. It would actually be sulfuric acid, just in a very diluted form. Now, SO2, to mitigate this, a lot of factories will use something called scrubbers, which is a chemical coating inside their smokestacks. This reacts with the sulfur dioxide using limestone. So limestone is part of what makes up the scrubbers, and it produces a chemical called gypsum. Or I shouldn't say a chemical, it's more a mineral, I believe is what it technically would be. Gypsum is this clear, almost, I don't know, stone looking stuff right here on the side. It has a bunch of various uses. I know sometimes people use it as, I think it's like a type of fertilizer. I know you can add it to your garden. But another use for gypsum is actually in industrial processes like making chalk. You can also use it to make things like drywall. Sometimes they even use it to make like plaster, right? So gypsum can actually be used in many certain situations. So this is basically what I'm saying here is this is an instance of using something that is actually a pollutant like SO2 and actually using it for a good thing, right? So in other words, using a scrubber to make gypsum, and then every now and then they collect the gypsum and then they can use it for some other purpose, or at least sell it to another company that can use it for a purpose. So it'd be much better in this regard than just being released into the atmosphere where it can make acid rain. Another type of chemical that can be released in the atmosphere is nitrogen oxides. Now, there's not any one type of nitrogen oxide, so we've called this NOx. X could be a bunch of different numbers. There's different nitrogen oxides. You don't need to know that too much, but basically nitrogen oxides of various forms can be produced mainly by vehicle exhaust, but it can also be produced, of course, from industrial processes. Now, this will actually form a brownish gas, especially if you have it in high enough concentrations. The issue with nitrogen oxides is just like with sulfur dioxide, it can react with other pollutants to form, it can contribute to acid rain. I'm getting ahead of myself here. But the other thing it can do, there we go, can react with other pollutants to form ozone at the ground level. We'll talk about this point in a little bit here. Like ozone is another one of the gases we're going to analyze today. We'll talk about why having ozone at a ground level would be such a bad thing. But again, just like the other one, it can also contribute to acid rain. And of course, we don't want that because acid rain can either damage crops. If there's a significant amount of acid rain or acid snow, it can find its way into water supplies, and that changes the pH of those water supplies, whether it's a lake or a river or whatever. And that can, of course, harm the life that's in there. So speaking of acid precipitation, here's some examples. We've got sulfur dioxide and nitrogen oxides finding their way up to the clouds from various sources of pollution. When it's up in the clouds, it's mixing with the cloud itself, which of course is just, water vapor. And this produces nitric acid from the nitrogen oxides, but it can also produce sulfuric acid from the sulfur dioxide. And of course, when that rains back down, that has, some pretty damaging effects in terms of the surrounding pH. It can harm plants, it can harm ecosystems in the water, all around not a good thing. All right, next pollutant, this is one I'm sure you're all familiar with, carbon monoxide, or in other words, just CO. Carbon monoxide is infamous for being the odorless and colorless gas that is known as a silent killer, right? So in other words, carbon monoxide is very hard to detect because it doesn't have a smell and it doesn't have a color, right? Now, how it forms is through incomplete combustion reactions. So in other words, anytime where there's a combustion, some sort of chemical burning, when that chemical doesn't receive enough oxygen, like actual O2 gas, it forms carbon monoxide as an incomplete byproduct, right? Now, this is a dangerous gas that can cause things like headaches or even sleepiness. And if you're exposed to it for long periods of time, it actually results in brain damage, which then turns, of course, to death. The scariest thing about carbon monoxide is, again, it starts with just a minor headache, but that very quickly transitions to sleepiness. And believe me, if you're in an environment with carbon monoxide, you do not want to be falling asleep because then you can't be getting out of it, right? So that's why it's such a big deal that you watch for carbon monoxide and have a carbon monoxide detector in your house so that you can be alerted if that were to ever happen. Also, a lot of it just comes down to, basic safety stuff. Like there are people who start their cars in their garage in their house. Well, some people say, oh, well, we'll just, crack the garage door open. They even say even having your garage door open doesn't help mitigate getting rid of all that carbon monoxide. So it's still not exactly the best thing to be doing. But certainly having your garage door closed and turning your car inside your garage with a garage door closed, that would be even worse. And of course, a lot of people do get harmed every year from that through carbon monoxide poisoning. Moving on, ground level ozone. I alluded to this just a little bit earlier. Ozone is found at the Earth's upper atmosphere. I'm sure you've heard of it before. It's way up here in the stratosphere. It serves as a protective layer because it protects us from a lot of the harmful rays from the sun. Ozone is actually an odorless and colorless gas, and how it's formed is it's just 3 oxygen atoms bound together. So it's O3. Different than O2, of course. O2 is the oxygen that we breathe. O3 is ozone. Now, the trouble with ozone is where it's supposed to be, up in the ozone layer. Of course, we're never up there breathing it, so we don't really care, right? It's up there, it's protecting us, we're good. But if ozone is forming at the ground level, this is actually pretty dangerous because it can cause some lung damage, and it can also actually start basically suffocating out the crops, right? If there's a significant amount at a ground level, you'd be talking quite a bit, but still, it's important to realize. Now, ozone, again, as I mentioned a few slides ago, it forms when things like nitrogen oxide combines with just heat at the ground level to produce this. So this little picture even kind of just sums it up very simply. It just says pollution plus heat and sunlight equals ozone. So those nitrogen oxides forming at the ground level from vehicles and from factories and such, that can create ozone if it reacts with heat and sunlight. So not good. Obviously, we wouldn't want that going on either, but it is a common thing, especially in very large cities. So yeah. Anyway, that's it. Told you it was a quick lesson. That was only, I think, somewhere around 10 minutes long. So what I want you to do is I want you to finish that monitoring assignment. Again, there were 3 sections to it. There was one on water, there was one on the atmosphere, and then there's one on air that we talked about today. Use your textbook as a resource, of course. All this information that I quickly summed up is found in there, and it is a good reference tool, at least while I'm away. And aside from that, best of luck.